In the previous video, I looked at exam-style questions involving addition and subtraction. I'm now going to briefly look at multiplying and dividing fractions. Here are two typical questions. Notice that for part B, we are dealing with mixed numbers. So, looking at these questions, do you know what to do? Why not have a go at the questions before I go through the answers? I'm going to go through the answers, and as I tackle the questions, I'm going to share with you my thinking. Starting with part A. Now, the beauty of multiplying fractions is that all you have to do is to multiply the numerators together and the denominators together. So we have 3 multiplied by 5 over 7 multiplied by 8, and this is equal to 15 over 56. And there's the answer. Notice that there are 2 marks for this question. You will be expected to show your working out for 1 mark and show the correct answer for the other mark. Now for part B. Here we are dealing with multiplying 2 mixed numbers. Essentially, before we multiply, we need to write these mixed numbers as improper fractions. This is where the numerator is larger than the denominator. Rewriting 1 1/7. Here's what I'm thinking. For this mixed number, we are dealing with sevenths. So each whole number is 7 over 7. So 1 and 1/7 is actually 7 over 7 add 1/7, which is equal to 7 add 1 over 7, which is equal to 8 over 7. Alternatively, we can think of this as 1 lot of 7, or 1 multiplied by 7, add 1 all over 7, which of course is 7 add 1 over 7, which is equal to 8 over 7. Do you see how this second approach works? Pause the video and have a think if you need to. By multiplying the 1 by the denominator of 7, we have created this 7 here. It's just a different way of writing it, but getting the same result. Similarly, for 2 3/4, we are dealing with quarters. Think of 2 as 4 over 4 add 4 over 4. So 2 3/4 can be written as 4 over 4 add 4 over 4 add 3 over 4. So that's 4 add 4 add 3 all over 4, which is equal to 11 over 4. Again, the way I tend to do this is by multiplying the 2 by the denominator of 4, we have created these 2 4s here. And this is equal to 8 add 3, which is equal to 11 all over 4. Now you can, of course, show this working out in your answer if you need to. But what you do need to show is that you have rewritten the original mixed numbers as improper fractions. We now have 8 over 7 multiplied by 11 over 4, which is equal to 88 over 28. Now, the question is asking for a mixed number in its simplest form. I'm going to do the simplifying of the fraction first of all. We can divide the numerator and the denominator by 4, which will give us 22 over 7. We can't simplify the fraction any further. On this issue of simplifying, we could have done the simplification earlier on when doing the multiplication. I'll show you what I mean. Here's the 8 over 7 multiplied by 11 over 4. Notice that we have a numerator here of 8 and a denominator here of 4. We can therefore divide top and bottom by 4. Sometimes this is referred to as cancelling down. So 8 divided by 4 is equal to 2, so this becomes 2, and 4 divided by 4 is equal to 1, so this becomes 1. So we now have 2 over 7 multiplied by 11 over 1. So this is 2 multiplied by 11 over 7 multiplied by 1, which is equal to 22 over 7. Essentially, all I've done is divide the top and bottom by 4 before doing the calculation, as opposed to dividing the top and bottom by 4 after the calculation. It is useful to do the simplification beforehand to avoid dealing with larger numerators and denominators, but that's down to you. But it is important to be aware of this, as you might be required to simplify your answer as shown in this example. The final stage is to write this improper fraction as a mixed number. We are dealing with sevenths, so I'm thinking of the 7 times table and thinking of each whole number as 7 over 7 or 7 sevenths. We need to get up to, but not go over 22, as there are 22 sevenths. Well, 3 lots of 7 is 21, with 1 left over. So I'm thinking that that's 7 over 7, add 7 over 7, add 7 over 7, which is 21 over 7, add 1 seventh, which is 22 over 7. So that's 3 lots of 7 sevenths and 1 seventh. So 22 over 7 can be written as 3 and 1 seventh. So for this type of exam question, the chances are that you'll be expected to convert the mixed numbers into improper fractions, perform the multiplication, then convert back into a mixed number in its simplest form to get all the marks. Let's look at questions involving division. Here are 2 questions. Part A. 3/8 divided by 4/5. Now, all you need to do with division questions like this is to change this into a multiplication by using the reciprocal of the fraction you are dividing by, which in this case is 4/5. Now, I am working on lessons which will look at this in more detail, but for revision purposes, it is assumed that you have covered this. But as a quick reminder, the reciprocal of a given fraction is the inverse of that fraction, such that when multiplying the fraction and its inverse together, you get the answer 1. So what that means here is that the reciprocal of 4 over 5 is 5 over 4. And if we multiply these together, we get the answer 1. So, to change this division into a multiplication, we write this division as 3 over 8 multiplied by 5 over 4, where 5 over 4 is the reciprocal of 4 over 5. We can now tackle the problem as a multiplication. So that's 3 multiplied by 5 over 8 multiplied by 4, which is equal to 15 over 32. And there's our answer. Of course, the same applies if the division involves mixed numbers, as shown here in Part B. 3 3/4 divided by 1 1/5. We begin by changing the mixed numbers into improper fractions. 3 3/4. Here we are dealing with quarters, so I'm thinking of each whole number as 4 over 4, or 4/4. So that's 4 over 4, add 4 over 4, add 4 over 4, add 3 over 4. This is 4 add 4, add 4, add 3, all over 4, which is equal to 15 over 4. Alternatively, think of this as 3 lots of 4, add 3, all over 4, which is equal to 12 add 3, all over 4, which is equal to 15 over 4. Now to change 1 1/5. Here we are dealing with fifths. So each whole number is 5 over 5, or 5/5. So 1 1/5 is 5/5 add 1/5, which is 6/5, or 6 over 5. Alternatively, you could have done this as 1 lot of 5 add 1, all over 5, which is equal to 5 add 1 over 5, which is equal to 6 over 5. Now we need to turn this division into a multiplication. We therefore need the reciprocal of 6 over 5, which is 5 over 6. So we now have 15 over 4 multiplied by 5 over 6. Now this time, I'm going to simplify the calculation before I multiply. I have 15 on top here and 6 on the bottom here. I can therefore divide top and bottom by 3. So 15 divided by 3 is equal to 5, and 6 divided by 3 is equal to 2. So we now have the calculation 5 over 4 multiplied by 5 over 2. So this is equal to 5 multiplied by 5 over 4 multiplied by 2, which is equal to 25 over 8. We can't simplify this fraction any further. And just to show you that we will get the same answer if we do the simplification after the multiplication, so 15 over 4 multiplied by 5 over 6 is equal to 15 multiplied by 5 over 4 multiplied by 6, which is equal to 75 over 24. If I divide top and bottom by 3, I get 25 over 8. So it doesn't make any difference to the answer if you simplify before the calculation or after the calculation. It's your choice. So the final thing we need to do is rewrite the answer as a mixed number. We are dealing with eighths. So I'm thinking of the 8 times table, and that each whole number is 8 over 8, or 8 eighths. We want to get up to, but not beyond, 25, as there are 25 eighths. I know that 3 lots of 8 is equal to 24 with 1 left over. So that's 8 over 8 add 8 over 8 add 8 over 8 add 1 over 8, which is equal to 25 over 8. So 25 over 8 is 3 1/8, and that's our answer. So in this question, you'll be expected to convert the mixed numbers to improper fractions, change from division to multiplication, perform the multiplication, and convert back to the mixed number in its simplest form. But there's some non-calculator fraction questions involving multiplication and division. I'm going to continue to make revision type videos at this moment to help those of you who are studying for your GCSEs. I hope you found this helpful, and thank you for watching.